QED stands for Quantum Electrodynamics, and it is a theoretical framework that describes the interactions between electrically charged particles such as electrons and photons. It is considered one of the most successful theories in physics, as it can explain phenomena with incredible precision, such as the behavior of particles in a magnetic field and the emission and absorption of light. QED was developed by a group of physicists, including Richard Feynman, Julian Schwinger, and Sin-Itiro Tomonaga, in the late 1940s and early 1950s. The theory is based on the principles of quantum mechanics and special relativity, and it describes the interactions between charged particles through the exchange of virtual photons. The basic idea behind QED is that the interaction between two charged particles can be thought of as a continuous exchange of virtual photons. When two charged particles approach each other, they exchange virtual photons that transfer energy and momentum between them. The more virtual photons that are exchanged, the stronger the interaction between the particles. Feynman diagrams are graphical representations of the interactions between particles in QED. They are named after Richard Feynman, who developed the technique in the 1940s. In a Feynman diagram, particles are represented by lines, and interactions are represented by vertices where the lines meet. Virtual particles, such as virtual photons, are represented by wavy lines, while real particles, such as electrons, are represented by solid lines. QCD stands for Quantum Chromodynamics, and it is a theoretical framework that describes the strong nuclear force that holds quarks and gluons together to form protons, neutrons, and other particles. QCD is similar to QED in that it is based on the principles of quantum mechanics and special relativity, but it describes a different force and a different set of particles. In QCD, the interaction between quarks and gluons is described by the exchange of virtual gluons, which are the particles that mediate the strong nuclear force. The more virtual gluons that are exchanged, the stronger the interaction between the quarks and gluons. Feynman diagrams are also used to represent the interactions between particles in QCD, but they are more complex than the diagrams used in QED. In QCD, the interactions between quarks and gluons can lead to the creation and annihilation of particles, which makes the diagrams more intricate. In summary, QED and QCD are both theoretical frameworks that describe the interactions between particles, but they describe different forces and different sets of particles. Feynman diagrams are used to represent the interactions between particles in both theories, but the diagrams used in QCD are more complex than those used in QED.